already see that all the z terms have either a -4 coefficient or a +4 coefficient. So that makes it really simple for us to accomplish that first goal of reducing our system of 3 equations and 3 variables down to a system of 2 equations and 2 variables. And since it's going to be most convenient to get rid of the z variable, this new set of equations is only going to have x's and y's, right? So I'll have 2 new equations that have just x and y. So I'll call that equation 1, equation 2, and equation 3, right? Equation 1, equation 2, and equation 3. I'm going to combine the first two, equation 1 plus equation 2, to get my fourth equation. And so 6x plus -2x gives me 4x. 4y plus 8y gives me 12y. -4z plus 4z gives me 0z, which is just 0. 12 plus a -52 leaves -40. Okay. Then I'm going to combine equation 2 and equation 3 to give me my fifth equation. So -2x and -5x gives me -7x. Positive 8y and positive 16y gives me positive 24y. The z's again will cancel out to 0. Then -52 plus -58 leaves -110. And I have finished the first major phase, which is to come up with a new system of 1 fewer equations and 1 fewer variable. Okay, I'm going to repeat that process where I reduce down to a system of only 1 equation in 1 variable. Now, looking at the 2 equations I have here, equation 4 and equation 5, it looks like the easiest thing for me to do is going to be to eliminate y. So that first equation, 4x plus 12y equals -40, when added to equation 5 would not make the y variables cancel out. But if I first multiply -2 on to equation 4, I will get a new version of equation 4 that is going to help me eliminate the z variable in the next step. Right, so first just multiplying -2 times positive 4x is going to give me -8x. Positive 12y times -2 is -24y. And then the -2 times -40 will give me positive 80. Then I don't need to change that fifth equation. I'm just going to rewrite it. -7x plus 24y equals -110. Now, I'm going to add these 2 equations together and get my final single equation in 1 variable. Okay, so adding those, I get -8x and -7x gives -15x. The -24y and the positive 24y zeroes out. The 80 and the -110 becomes -30. Now I can easily solve for x by dividing -15 on both sides. And the -15 divided by -15 becomes 1. 1 times x is just x. And then -30 divided by -15 gives positive 2. So now I have the first variable value solved, and this unlocks the rest of the problem. So now I'm just going to work my way backwards. I'm going to take this result back to my system of 2 equations and 2 variables and find y. Then once I have the y, I'll take both the x value and the y value back to my system of 3 equations and find the z variable, right? So I'm going to put that 2 in for my x and move on to the next part, which is to use one of the equations from this set equation, either, twisting my words. I want to use either equation 4 or equation 5. So let's use equation 4. Doesn't matter which one, but I'm just picking 4. And here's 4x plus 12y equals negative 40. But I'm going to replace the x with the x value I just solved for in the previous step. So 4 times 2, which simplifies to 8, then plus 12y equals negative 40. And now I'm just going to go through the steps of solving for y. So I'm going to subtract 8 from both sides. That gives me 0 plus 12y, which is just 12y on the left, equals negative 48 on the right. Then to undo 12 times, I'm going to do divide by 12 to get y alone, because 12 divided by 12 is just 1. 1 times y is just y. And negative 48 divided by 12 is negative 4. Right, so now I have the second value for my ordered triplet. And now I can bring those two results back to my system of 4 equations. Or, I'm sorry, excuse me, I meant to say my system of 3 equations, the original system. And I can choose equation 1 or equation 2 or equation 3 to work with, and it does not matter which one I pick, right? I'm going to go ahead and choose equation 1 for really no particular reason. So I'll go ahead and just write equation 1, which is 6x plus 4y minus 4z equals 12. Now I'm going to replace the x with 2. And replace the y with negative 4. And now I'm looking for z. Okay, so I'm solving for z. It's the only unknown left now. Okay, so I'm just going to simplify first. 6 times 2 is 12. 4 times a negative 4 is a negative 16. Then I just copy down negative 4z equals 12. And simplify. 12 minus 16 is negative 4. Bringing down the rest. Now that I have simplified the left side, I'm going to start solving, which means I'm going to get rid of things until z is all by itself. So I'm adding 12 to both sides here. What? Why did I add 12? That's not what I meant to do. I meant to add 4 to both sides. I'm just trying to get everything away from the side that z is on. So negative 4 plus 4, that zeroes out. Then I have negative 4z, and 12 plus 4 is 16. Then dividing both sides by negative 4. This becomes 1, just like that became 0. 1 times z is z. And I know my z's probably look weird to you, but this is just a habit I've gotten into over the years of doing math so that I don't get confused and think that this is either a 7 or a 2. All right, so now I have my z equals negative 4. And at this point, what we really should do is take each one of these equations in turn. Maybe not the first one, because we just used the first one to get this last result, but at least take this ordered triplet back to equation 2, verify that when you plug those in, you get a true statement, and then see if it also works for equation 3, because this ordered triplet has to work for all 3 equations in order for it to count or to qualify as a solution to the system. I'm not going to spend the time to do that here, but I do want to encourage you to do that if you have the time. Also, I want you to be able to write the solution set. So this is another thing that you might be asked to do, is to write the solution set. Okay, so this may seem a little odd, but when you provide solutions formally, you usually give them in set brackets. And if you have one variable, there would just be the values separated by commas. That would make the equation true, right? Or if in this case we have three variables, what we're going to actually have are ordered triplets, just like you see here, right? Just like the solution we gave. So this is a set that only has one solution, and that is that single ordered triplet we just came up with by doing all the work. Okay. And so this is one of three different cases that can happen when you have a system of equations. Either that system could have just one single solution point, or it could have no solutions at all. And then if it was no solution, it would just be the empty set, also sometimes written as the null set. Or a third possibility is that you could have a dependent system where it's infinitely many solutions. But the ones that you're going to be the only kind I'm going to give you on the test is one that has a single solution. So this is how I would like you to give your solution when you write it on your paper. All right, I hope that was helpful, and I will see you in the next video.